Good morning student, welcome to the physics lab. Today we are going to study the law of resistance using a meter bridge. The name of the experiment is Wheatstone meter bridge laws of resistance. The aim of the experiment is to determine the laws of resistance in a series parallel using a Wheatstone meter bridge. So the formula for this is Rs is nothing but R is equal to mean Lx upon mean Lr, and we'll calculate both the values for the series and for the parallel. For the series we have the formula Rs is nothing but R1 plus R2, and for parallel we have Rs is nothing equal to R1 into R2 upon R1 plus R2. The observation for this experiment is resistance from the resistance box, balance length of a resistance in the series, left gap, right gap, mean Lx, mean Lr, and ohms, the right mean value about these. So we'll calculate same as in the parallel also. So first of all we'll have apparatus to conduct the experiment. We require some apparatus. The apparatus will be the meter bridge, battery eliminator, galvanometer, resistance box, and Wheatstone meter bridge. So we'll see the circuit now. Okay, students, laws of resistance using meter bridge. The aim of this practical is to verify the laws of combination, series and parallel of resistance using a meter bridge. Apparatus, meter bridge, two resistance, galvanometer, resistance box, cell, rheostat, jockey, plug key, connecting wires. So this will be our diagram, and in this diagram we'll have resistor in series. If both the wires are connected in the series in the same fashion, in the same way, that will call the series, and parallel 1 upon, this will call the parallel. So first we will see this diagram, the connections, and it's very simple. Just we need to connect in the series and then into the parallel and take the readings. Now formula for this, for the series combination is Rs is equal to x1 R1 plus R2, and for the Rp is equal to R1 into R2 upon R1 plus R2. Over here is x given, it doesn't matter, you can write x also and you can write R also. The procedure for the arrange and connect the circuit for the series combination. First we will do this experiment for the series combination. Take some suitable values of resistance from the resistance box and then close the plug key. Touch the jockey at the point A and C of the meter bridge wire, so the galvanometer will be deflection on either side of 0. So we'll check whether it is been getting 0 or not on this meter. The same as follows for this, the last experiment we have done it. So we'll see now the connection. A diagram is very important, so we'll go accordingly with this diagram. First we'll see what are the apparatus over here it is being used. Okay students, this is the direct current we are getting 240 volts, and this is a battery eliminator which we can have the volt as per the requirement of this practical 2, 4, 6. So I have kept the 4 volt. So this will be the output will be the 4 volt. We are getting the direct volt of the 240, but we are getting for performing this experiment 4 volt. Now this slide, this box is called as a meter bridge. This is a resistance box. This is a resistance box. We have the resistance from 1 to 500 ohms. So these are the plug keys. Before join this, you need to check whether all keys are pressed or not properly. It should not be loose. So I have checked this one. This is a key, this is a galvanometer. Now we are using a in series way, so I am getting a 10 ohms 2 series wire over here. This is a galvanometer, this is the strip, and now we will see the connection. Now students, now in connection you need to be very careful. The positive terminal of the galvanometer I'll join over here, and this will come to the Bridgestone left hand side. See, this is the wire, this is come to left hand side of the Bridgestone meter bridge. So Now the negative terminal of the battery eliminator, I have joined this wire to plug. Key, this is joined over here. Now from key I have joined to the left hand side of the Wheatstone meter bridge. So directly over here, see the connections properly. This I have joined over here. Now coming to the next connection, this is the resistance box from where we require the resistance. We'll take the output from here, how much we require. So this key I have joined here, this wire, positive, it's nothing called as a positive negative, but these two connection will be here, left hand side of the Wheatstone bridge. Then galvanometer in middle part I have joined the galvanometer. Positive will come to the here. Generally in galvanometer there is nothing called as a positive or negative, but to avoid the confusions we are given the sign the positive and negative, that's it. So you can join accordingly. So the positive one I have joined over here in the middle of this part. Negative, this black wire will go to the jockey. I have joined this jockey. This, see, on every instrument you have this kind of a screw. What you need to do, you need to take a wire and it should rotate in this, and it's fixed. The connection should be in proper and neat, so the experiment will perform, it would have correct readings. Now in series I have taken the 2 ohms, I have connected in the series in this in a left right path. See, one connection I have connected to this and one connection I have connected to this. So this is connected in the series. Now we'll start the performing of the experiment. So we'll start the output. Now battery eliminator has been on. I have kept on the 4 ohms. You can keep on the 2, you can keep on the 4 according to your wish, 2 or 4. Now I'll see whether my connections are right or whether it is connected truly right or not. See, when I touch jockey on the slider, the galvanometer should deflect. If I am touching to the right hand side, it should go on the right hand side, and when I touch to the left hand side, the galvanometer go on the left hand side. So I touch here, so it's not moving. It's not moving. Now over here, one of the basic point you should understand that I have on the eliminator, connections are proper according to me, but the deflection I am not getting on the galvanometer because of I have not plugged the key. This is one of the most important thing. You need to put the key. If you don't put the key, you can't take the readings. And while taking the readings, only you need to plug the key. Otherwise, remove it. So I plug the key. Now I'll check whether the deflection is there or not of the galvanometer. Yes, it's there. The jockey. One of the best thing of the jockey is that you are not supposed to slide the jockey on this metal strip. You are supposed to touch. Otherwise, some students they do like this, slide it. No need to slide. Just put on this. On this hand side, my connections are perfect. Now I'll see the left hand side. Now see, galvanometer is deflecting on the left. This is, the connections are absolutely right. Now we'll take the readings. We'll take the first reading. Substitute value we need to take out from the resistance box. So I'll take a 15, 10 plus 5, If we will see A15, I have removed keys. This is 10 and this is 5. This is a 15. It's 15. Now I'll search for the null deflection on the galvanometer. It's deflecting. It's deflecting. It's deflecting. It's slightly deflecting over here. Now little more. This is deflecting. Yes. 61. I am getting the null deflection on 61. So I'll take the reading as a 61 for LX. LX is nothing but 61. So I'll take in a small exam. For resistance box 15, I have get LX centimeter is nothing but 61. So LR centimeter, 100 minus 61 is nothing but 39. This is our left cap. The same procedure we need to follow in the right cap. Just interchange it, put it on this side and take the readings. That's it. So I am going to take the left hand side. Now I have taken the readings for the 15 ohms. Now I will go for the 20 ohms. So I will put this 5, 10 and I will remove 20 ohms. I have removed 20 ohms. If you will see, I will take the reading for the 20 ohms. Now again we'll find out we'll see what is the deflection point for this. Touch the jockey on the slider, is deflecting, is deflecting, is deflecting, deflecting. Is deflecting somewhere here. I'll get it. (53). I am getting a null deflection on 53 centimeter. See, 53. I touch it over here. It doesn't have deflection. If I go for the 54, is deflecting. Is deflecting. 53. I have gotten a reading. So next reading for 20 ohms is 53. I'll see next part. Now we'll go for the 25 ohms. 20 and plus 5 ohms I have removed from here. Now we'll see the null point. No. Deflecting. (47). I have gotten a null point on 47. See, if I go ahead about this, is deflecting, but on 47 it's not deflecting. So third reading, you need to take a 3 readings for series and parallel. Left hand side, left cap and right cap. 3 readings. That's it. So now for this third 25 ohms, which we have got the readings, it's somewhat 47.2. So now if you go okay, now this was for the resistor in the series. Now we'll take the readings for the resistance in parallel. So what you need to do, you need to connect this in the parallel. So what I'll do, I'll connect this in parallel way. Now this I have attached in parallel. So we'll see the connection along this. I'll put all these keys on the resistance box. We'll see whether our connections are right or not. Yeah, it's deflecting. On right hand side, it's deflecting. On left hand side, it's deflecting. So connections are in the proper. Same way, I'll go for the reading over here for the 5 ohms in parallel series. I'll open the key from resistance box of 5 ohms. I've kept over here. If you'll see, I've removed the 5 ohms. So now I'll take the readings for 5 ohms. So I'll see whether it's the null point. Okay. Now I am getting the reading over here on 49. I have got a reading 49 centimeter as a null deflection on 49. So I'll write over here 5 ohms, and this is in the parallel. First observation 5, then I'll take 7, then 10, then this is a 49. Now over 7, 5 plus 2, 7, 2 ohms I have removed. Now it would be in below 49, so we'll check from 37. (44). I have got a null deflection on a 44. So I'll write here 44, and on 10 ohms I'll put all these keys again. I'll remove the 10. The null deflection I've got over here on a 31. If you'll see 31. So 31. This is a left cap, this is a right cap. 61 minus LR is nothing but 100 minus LX. So it's 39. 53 minus 100 is 47, 52.8, and in parallel series 49 it's 51, 56, 69. The same goes with the right hand side on same. So the calculations, I'll show for the first one. R1 plus R2, R mean LX value, R was 15 and LX was 56.65. Log of 15 is nothing but 1.1761 plus log of 56 is 1.7532. Addition of this is 2.9293. This will called as A. And mean LR of RS is 43.35. So we'll minus A minus B. So this come minus 1.6370. This I'll call the B. So now minus A minus B is nothing but 1.2 2923, where anti-lock is 19.60. The same way you need to go for all the readings and do the calculation. Conclusion of this experiment is, since the expected value of the experiment value for the series combination are same, limits of the parallel cross the law of resistor in series and parallel combination, it has thus verified. See, there might be some difference, 2 points, 5 points, 8 points. So actually know the difference of this theoretically and practically, we do have a difference. But the thing is that everything is not perfect. It doesn't work on the 100% efficacy. So this minor deflection, it's okay. इतना हम ले सकते हैं, कोई उसका issue नहीं है. So hence the practical is verified. You need to take in the parallel series and then in series combination. After that, we have to take the readings from the left hand side, left gap, and then the right gap, interchange it, and your experiment is done. Thank you. Okay students, the way we have taken the readings from the experiment, I have jot down on the board. So for in the series, this table is for the series and that table is for the parallel. In series, we have taken the 15, 20 and 25 ohms, and the reading for these are the 61. Now this is LR is nothing but 100 minus 61 is 39, then right gap, then mean of LX, this plus this divided by 2 is 56.65, and LR is 43.35, and this is nothing but mean LR is nothing but R is equal to 19.60. Over here 15 into this divided by this, so we will get the 19.60. The same goes on these calculations, and over here in parallel also same we go, and this calculation you need to do for the each and every value. For the in series 15, 20, 25, and in parallel 5, 7 and 10. I have shown one calculation, you need to perform all the calculation, you need to write in your journals. So for the 15 in the series, symbol R, value 15, log of 15, 15 log is nothing but 1.1761, and mean LX 56.65, mean LX 56.65. Now this log is nothing but 1.7532. Adding both the logs, we get 2.9293, will call as a. Now mean LR is nothing but how much? 43.35. Now 43.35. Now this log is nothing but minus 1.6370, will call as a B. Now A minus B, we need to minus this from this, we get 1.293, and that is nothing but anti-log 19.60. You need to perform all the calculation for the values of 20, 25, unparalleled, 5, 7 and 10. Hence the formula has been given, you need to add it. Thank you very much.